Hello everyone. Good morning. The authors and invited guests. I welcome you all to the technical session 8E. Myself, Siddesh Mughal, and this session will be moderated by me. On the behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 9th International Conference on Information and Communication Technology for Intelligent System, ICTIS 2025, Bangkok, Thailand. The ninth edition of the conference is organized in hybrid mode. The physical event was held on 4th April in Bangkok, Thailand, and the virtual event is being held through Zoom yesterday and today, that is 5th and 6th April 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for the question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that they all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. So just before we start the session, I would like to introduce you all to the chair of the session. Our chair of the session is Dr. Disha Wankhede. Dr. Disha Wankhede is currently an assistant professor at Vishwakarma Institute of Technology, Pune. She has 16 years of teaching experience. Her skills and expertise lies in machine learning, computer vision, artificial intelligence. Her research area includes deep learning and image processing in healthcare and agriculture domain. Ma'am, would you like to give any opening remarks to participants?
Yeah, good morning all. Welcome to ICTIS conference held in Thailand. Yes, I have just give the best wishes. I'm expecting that your research contributing to this society, okay? and definitely it's one of the milestone for your research. So best of luck for you. Give your best. Thank you.
Thank you so much, ma'am. Now I would like to start with the presentations. The first presentation is presented by Mr. Vishnu Kumar. He is presenting the paper title Benchmarking Machine Learning Models for Predicting County Level Suicides in the US. Sir, are you there?
Yes, I'm here.
Okay, sir, just a second. Yes, sir, now you can share your screen.
Okay. Can you see my screen?
Yeah, sir, it's visible. You can start.
Okay. Well, good morning, everyone. My name is Vishnu Kumar. I am with the Morgan State University at USA, and then today I am here to present my research on benchmarking machine learning models for predicting county-level suicide in the United States. So, suicide has becoming a big healthcare problem in the United States, recording at least 30% growth in the last 20 years. So as you can see from this graph over here, it has been constantly increasing over the last 20 years or so. Now, suicide has also become one of the top leading causes of death among all age groups in the United States, and therefore is posing a significant health concern in the United States and needs urgent attention. Now, there has been a wide number of resources that has been published both by the federal government, state governments, and other non-governmental organizations to curb and prevent suicides and control its effects. Now, there has been some other publications. There has been a lot of resources that has been available for the people. There are also some help resources available, but still the suicide numbers continues to grow. Now, this means that we need to have some extra research that can help us prevent and control the suicide across the country. Now, there has been some research done in the past. So traditionally, people have been using statistical methods to study suicide and also predict the factors relating to the suicides. Now, one of the problems with some of these statistical models has been their issues with accuracy, which has already shown some limitations with their ability to predict suicide accurately. And also, they have some of these studies that using traditional methods have shown problems identifying and capturing all this nonlinear interaction between the different variables. Now, apart from this, most of these traditional studies often use national or state level data, and some of these therefore miss some of the local disparities that affect suicides. Now, to solve some of these challenges, people have now moved to machine learning-based approaches. So many of the works been done in the past with respect to machine learning involve studying suicides from an individual level. So in most of this work, people look into some clinical level data, interaction of people with social media, some of their social media posts, and how that might talk about suicide risk, so on and so forth. But most of this work focus on an individual level. But then there has been a significant gap with respect to identifying what are some of the geographical factors that can affect suicides. And identifying some of these geographical factors can help us make some changes in the policies with respect to public health and suicide prevention. Therefore, more investigation is needed at a more localized level using some of the contextual factors that affect a particular geographical regions. The contextual factors include socioeconomic, healthcare, and other demographic factors of a particular region. Now, in this work specifically, I'm focusing on a county level analysis of suicides. So I pick county levels because that is the most finest grained geographical unit from the CDC, which is the Center for Disease Prevention in the United States. So at least in US consists of 50 states, and each state is further divided into a wide number of counties. So in this work, I'm focusing on a county level analysis to understand what are the different contextual factors that can affect suicides. Now, understanding that pattern helps us detect some localized changes in suicide rates and also supports targeted public health interventions. So this picture here shows the different counties present in the United States. And all these counties that are shown in the darker regions have had a larger increase in suicides over the last 8 years. The counties that are shown in the lighter shades have had very small or no change in the suicide rates. So as you can see from the picture here, some of the counties that are in the east side of the country and also the west side of the country has seen some significant increase. So therefore, we can see that there's some geographical disparities on the suicide trends across the countries over the last 8 years. So the main agenda of this research is to first collect some county level data on some of the contextual factors. So contextual factors include some of the socioeconomic, healthcare, and also demographic factors for each and every county in the country. Now, once you collect the data, then I train about 11 machine learning models to predict the suicides. And then I do a benchmarking of this machine learning models to assess their performance on their ability to predict suicides. Now, the overarching goal of this work is to boost targeted and localized suicide control and prevention efforts. So now I'll quickly move over to the methodology. So the first step is data collection. So in this work, I collected about 8 years of data for about 3,140 US counties, and I collected 12 county level features. So the county level features include a variety of socioeconomic, demographic, and healthcare related features as shown in this table here. And all this data was collected from public available data sets that were freely available from all these government websites listed here. So once this data was collected, then I did a correlation analysis to identify the features that were correlated. So features that are correlated would carry the same amount of information. So then one of the features could be removed from further analysis to save computational time and resources. In this work, I set a correlation coefficient threshold of 0.75. So any features having a correlation coefficient more than the absolute value of 0.75 would be highly correlated. But in this work, at least, there weren't any features that were highly correlated. So I still use my entire data set for this analysis. Now, once that step was done, then I selected all my machine learning based models. So in this work, I'm using linear models, tree based and ensemble models, and some distance or instance based model, including the k nearest neighbors, and then support vector regressions. All these models were created using Python and with the dependent variables set to suicide deaths, and independent variables include all the different 12 county level features that I just showed earlier in this table here. Now, I did split the data into the testing and training set, and I also did a cross-validation to avoid overfitting and other issues. And the main idea was to benchmark all the different models using their the usual metrics such as the R-squared value, the RMSE, MAE, the training time, and also the inference time, that is the time taken to make the predictions on a new data sample. So now I'll quickly go over to the results. So my results show that among all the different 11 models that I picked for the analysis, the XGBoost model seemed to be the best performer. So there was a big trade-off between the other models, but XGBoost seemed to have the highest R-square value, the lowest RMSE and MAE values. It was able to train in a very low amount of time of 1.7 seconds, and the inference time seemed to be very less. So overall, XGBoost seems to be a better model in predicting suicides with respect to all the other 10 models that I used in this work. Now, as I mentioned, XGBoost seems to have the highest performance, and the worst performing model was the support with vector regression that showed a very poor R-square value with the highest RMSE value. So the basic conclusion as well, XGBoost seems to be the best model for suicide prediction, offering high accuracy and efficiency. And Ensemble's models in general did show some good performance, whereas some of the linear models and the other distance-based or instance-based models, such as the SVR and k-nearest neighbors, struggle with accuracy. Maybe they have some issues with analyzing the linear interactions between the variables used in this work. Now, this work also I did identify some limitations with work. So one of the biggest limitation is the possibility of some misclassification. So since all this data were obtained from public data sets, there can be chances where a suicide may be misclassified as some other sort of maybe homicide. And also there can be cases where their deaths that is due to suicide may not be classified as suicide. So there can be some misclassification in there. And also this data set included the suicides that were actually reported. So there can be cases where suicide may go unreported and that may not be covered in the data set that I had. And in this work, I used 12 county level features based on the data availability, but there can be some other features which I may not have included. And the extent of all these things happening is currently unknown. Now, I do also have some future work that I plan to conduct. So one of the future work is, again, address the privacy concern and ethical concerns with using AI models, and also trying to enhance the transparency of this AI models. So that is something that I wanted to do. And another area that I'm trying to implement is some time series-based forecasting. So since I'm using about 8 years of data, I'm trying to collect more amount of data, maybe for a 10-year or maybe 15-year period, and then trying to see, maybe create some sort of a time series forecasting model that can track the changes in suicide across this 10-year period. So that is some extra work that I plan to conduct in the future. So with that, I come to the conclusion of my presentation. Thank you so much for your attention, and I'm open to any questions that you might have. Thank you.
Very good, Vishnu. You had done a very nice job. I have one question.
Sure.
Okay, so during your work, how do the feature some important features which is you have already shown to here? Okay, so it may vary across the different algorithm.
So the impact of each feature on the output is something that I did not check. There can be, of course, I'm pretty sure different algorithms might work differently, and there might be the impact of different features on the output might be different. So that is something that I have not checked. Maybe I can, maybe I think I pretty much maybe for XGBoost, at least since it's the best performing model, I could do some feature importance that I think the XGBoost comes.
Actually, why I just asked this question because it's a social issue, and we need to identify that which features are mostly impacting to the particular this case, right? So you need to be in future, you have to analyze these things. Secondly, you have done any hyperparameter tuning during your study or during your implementation?
So I did not use hyperparameter tuning. I just did just as cross validation, 5-fold cross validation, and then yes, just a cross validation.
That part also you have to add in your research. Okay.
Sure. Yes.
Okay. Okay. Very good.
Okay. Thank you so much for the inputs.
Thank you, sir. You can stop your presentation. Okay, so up next, Mr. Mohammad Rabi Pudir. He is presenting the paper titled Enhancing Stress Detection Using Bayesian Optimized Boosting Algorithms and Feature Analysis Using SHAP.
Yes, I'm present.
Okay, sir, you can start your presentation.
Good morning, everyone. Myself, Mohammad Rabiuddin. Today, I will be presenting our work, which is on enhancing stress detection using Bayesian optimized boosting algorithm and feature analysis with SHAPE. Stress is a critical health concern, and our work aims to improve its detection using advanced machine learning techniques. Let's dive into the details. Where is the outline of my presentation? Those will be covered in this presentation. Motivation of the research. Stress has a profound impact on both physical and mental health, leading to conditions such as anxiety, depression, and cardiovascular diseases. Addressing these issues align with the Sustainable Development Goal 3, which emphasizes the importance of promoting mental health and well-being. Accurate, thorough, and precise detection of stress level is crucial for understanding and managing its effect effectively. Machine learning models play a vital role in this process, offering enhanced insight and better interpretability. Particularly for datasets ranging from small to medium in size, stress has a profound impact on both physical and mental health, leading to conditions such as anxiety, depression, and other also. Addressing this issue aligns our sustainable development goals, and our precision, rigorous, and accurate detection is essential for understanding this level detection. In this in the next part, in the literacy review, in this table provides a comparative overview of 10 research studies focused on stress detection, outlining their objective, methodology, and limitation. The objective vary from detecting stress using biosensor. They are using deep neural network. In here, limitation, you can see that lack of details on the applied feature extraction technique, classification algorithm, potential overfitting due to small data size. Particularly, the models employed across these studies include deep learning, such as DNN and convolutional neural networks, as well as traditional machine learning approaches like support vector machine, KNN, and hybrid methods such as SPM combined with AWS. Despite their contribution, these studies share several limitations, including reliance on small dataset, lack of real-time processing capabilities, and insufficient validation across diverse populations. Much of existing research relies on deep learning models, which, while powerful, are often complex, resource intensive, and less suitable for small to medium-sized data. Many studies fail to comprehensively address stress levels, typically focusing on one or two parameters rather than incorporating a broader range of stress indicators. Additionally, XGBoost model, known for its own precision and efficiency, has been underutilized despite its potential in stress detection. The generalization of machine learning and deep learning models continues to face significant limitation, restricting their applicability across diverse population and environment. Additionally, there is a lack of adequate focus on secure data transmission and robust privacy protection mechanism, which raises concern about the potential risks associated with handling sensitive psychological data. The shortcomings highlight the need for improved security framework and models that are adaptable to varying context and datasets. This research has two key goals: develop and optimize stress detection model using boosting algorithm like XGBoost, AdaBoost, and CatBoost with Bayesian hyperparameter tuning for peak performance. And another one use step analysis to interpret prediction, identify top features, and select the best model based on evaluation metrics. Here is the flowchart of my work. In the first step, you can see the data collection and analysis, the examine stress-related data set, data cleaning, and data visualization after the data pre-processing, then model training, hyperparameter optimization. Here already we can see that we are using the Bayesian methods to fine-tune model setting, then model interpretation by shape analysis, is prediction and identify the key stress indicator. And after that, the model evaluation will be based on accuracy, F1 score, ROC curve, precision, then the final model selection. Different model architecture. In here already we are saying that we're taking XGBoost, different boosting model, XGBoost model, AdaBoost model, and also CatBoost model. In this table, the Bayesian hyperparameter optimization. In this table, for different model, we are taking different size space for hyperparameter optimization. There's all the values are shown here. In result part, the table compares the performance of boosting models, AdaBoost, XGBoost, GPM, and CatBoost for stress detection before and after hyperparameter optimization. In here, we can see that XGBoost providing the highest accuracy, maintains near perfect precision, recall, and F1 score. Score for post optimization, demonstrating its robustness. Anotherly, we can see that in AdaBoost shows the less accuracy, less precision, and F1 score also. The results highlight how Bayesian optimization enhance model performance across all metrics, with XGBoost model emerging as the most effective for stress detection. Evaluation evaluation matrix comparison for boosting model here in this table. Key evaluation matrix: accuracy, precision, recall, F1 score across boosting models for stress detection. It visually demonstrates that XGBoost superior performance, consistently outperforming other models in all metrics, particularly in accuracy 99% and F1 score 99%. Also, the chart highlight how Bayesian optimization improve its model predicted power, with XGBoost maintaining the highest score. Here, confusion matrix for XGBoost classified different stress level: normal, high. It shows excellent performance with 1 for characterization for normal and minimum classification 0 to 1 error for high. The figure 8, ROC curve analysis for multiple stress classification across different models. The plot demonstrated exceptional performance with AUC values approaching 1 perfect classification, particularly for the Bush model, indicating strong ability to distinguish between multiple stress level. And in figure 9, step feature importance across models, leaving consistent top predictor like heart rate, stress level, 0.35 to 0.50 impact score. Similarly, if the short authenticate feature suggested advanced feature extraction was employed, heat map style visualization clearly shows that drive prediction most significant across all the models. This study demonstrates that XGBoost, when optimized with Bayesian optimization and Bayesian hyperparameter tuning, achieve exceptionally 99% accuracy in instant detection. Surprisingly, the other boosting algorithms like AdaBoost and CatBoost, shape analysis provide model interpretability, identifying body temperature, step count, and body pressure as the most significant psychological indicator of stress. The future was focusing on 3 key improvement to advanced stress detection technology: fast expanding dataset diversity across demographic, and refining feature selection will boost the model generalization capability and classification accuracy. Second, enhancing interpretability through explainable AI techniques, and integrating multi-source data from wearable device. Finally, deploying the optimized model through a web or mobile application will enable real-time stress monitoring, making the technology accessible for practical every day. These steps aim to bridge the gap between research and real-world implementation, creating a robust tool for personalized health management. Here are all the reference we're using. Thank you. Is there any question?
Yes, Mohammed, I have one question.
Yes.
Okay, so during your study, what specific features were the most influential according to the shape analysis?
So I
Any,
didn't get your question.
which feature?
Ma'am, which
Am I
feature?
audible? Hello?
Yes, ma'am. I can
Actually,
I can hear you,
yes,
ma'am.
yes. Actually, whatever the features you consider no, from your data set and what in your implementation part.
We are taking body temperature, step count, blood pressure, and also oxygen level.
So how this particular, if any particular feature is influential according to your shape analysis? That is my question. I'm not asking you the general features, any psychological or behavioral, any particular features are influential or impactful in your shape analysis?
All my degree.
Okay. So you make sure that this is actually again the one of the important social aspects, stress detection.
Yes,
So
yes.
you need to be focused on which features are mostly impacting towards this stress detection in the society. Okay.
Okay.
And you are claiming that 99% using this XZ right? So you
Yes.
have to make sure that which features are mostly impacting, right? Okay. Yeah.
Okay. Thank you.
Yeah.
Thank you, sir. So, just a sec.
Can I start my presentation? I'm Kamran, though actually I had some internet problem earlier, so I have sorted it out.
Okay, sir. We'll
Mhm.
proceed with your presentation. Just a second.
Mhm.
So now Kamran sir is with us. So we will proceed with his session.
Sure, I'm
He's
sharing my screen.
presenting just he's presenting the paper title Eco Design in Dry Type Transformer, a comparative study of Tier 1 and Tier 2 classification. Okay, sir. Now you can start.
Can you allow me to share the screen, please?
Yeah, sir. Now you can share your screen. Just try again.
Okay, sure. My screen clear to everyone?
Yes, sir. You can start.
Okay. As our respected chair told, the topic of my presentation, Eco Design in Dry Type Transformer, comparative study of Tier 1 and Tier 2 classification. I'm Kamran Daud, working in the Extra Energy as a senior R&D engineer. At the same time, I'm a researcher at the Istanbul Technical University. My co-authors are Güven Komurguz, Furkan Gezer, and Samit Dursun. Let's see some contents of our presentation. First, I will give some introduction. Then we will see some key standards and regulation and specification of dry type transformer. What type of standards we are following, which kind of regulation and specification we have. Then we will see the results and discussion, and then I will conclude my presentation. As you know, that power transformer is widely used in the different application, from power distribution to the transmission in the different industrial units. The stability and availability of the electrical power is mainly depend on the working of the transformer. Electricity to the supplied area is mainly reliable due to the working of the transformer. As a transformer engineer, we are working in the several and different parameters of the transformer to improve the working efficiency, cost, and stability of the transformer. When we talk about the main topic of the transformer, these are generally core losses, copper losses, leakage reactance, leakage impedance, short circuit current, electromagnetic forces, and some type of other losses as well, like different type of the nodal losses. So these are the some of the main losses we are working. Excuse me. When we design the transformer, different customer ask for the different international standards. So in the design of the transformer, we must have to adhere to international standards recognized by the different standards, such as the IEC, IEEE, and the new one, EU 548, which is generally working in the Europe. It is divided into two tiers. First tier is built to meet the fundamental performance benchmark, demonstrate higher nodal losses as compared to the tier 2. When we talk about the Tier 2, these are designed to conform to more stringent efficiency standards, show a notable reduction in nodal losses. In this work, we have compared these two tier transformers. These are actually new work started from the 2014, and then it is going towards the now up till now. So these results serve as a crucial resources for transformer designers, power utilities, and end users, offering guidance in selecting the most suitable transformers based on both operation efficiency and economic considerations. These are the key standards and regulation we are working for. When we talk about the different standards, as I already told you, we have to meet different performance and safety criteria, which is recognized by the different standards. These are some of these are IEC, as I already told you that stand for the International Electrotechnical Commission standards, ANSI,
it is generally applicable in the USA, American National Standards Institute, and then IEEE, and EU number 548, which was started in the 2014. I already told it. Tadashi specifications. This is generally for in the area of the Turkey, different part of the Turkey. So another one is UL, Underwriter Laboratory Standards. So these are the main standards as a transformer designers we are working for. On 31 May 2014, Commission Regulation number 548 2014 was adopted. It was generally started or regulated in the 2009 of the European Parliament and the Council concerning small, medium, and different large transformers. The main goal of this transformer or this regulation is to minimize the losses to 16.2 terawatt hour per year by 2025. To achieve this, this was divided into two types. I already told it, Tier 1 and Tier 2. Let's see some results. So how it affects the results of different parts. So when you talk about the Tier 1 and Tier 2, there was a different, we have a, can you give me 1 minute, please? I think I have some problem with the. Okay, as we see, now we can see on the screen that in the different standards, we have a different limits, starting from the 15 kilowatt ampere to the 1600 kilowatt ampere. We have to be in the limit of these losses. Actually, I have some problem with the PPT and I didn't resolve it. Let's see the results here. Okay, we have designed a transformer with the nominal power of 1600 kilowatt ampere. The nominal primary voltage was around 20 kilowatt. The nominal secondary voltage was 0.4 kilowatt. The nominal primary current of the transformer was 46.19 ampere. The nominal secondary current was around 2309 ampere. The connection was DYN. Winding material used was the aluminum, and the material of the core was H0. So if you see the results of the transformer, these are the experimental results. You can see that we have to in the limit. If you see the load losses in the table 6, we don't have a change in the load losses when we compare the limits of the transformer for the Tier 1 and Tier 2. For both type, it is around 13 kilowatt. When we see the experimental result, it was in the limit. For the Tier 1, it was around 12.98 kilowatt. For the Tier 2, it was around 12,960 watt or 12.96 watt. Because in the both Tier 1 and Tier 2, we have to be in the limit of the 13,000 kilowatt. When we see the nodal losses, there is a difference in the limit. So we have to be in the limit, that limit. For the Tier 1, it was around 2.2 kilowatt. And for Tier 2, it was around 1.98 kilowatt. When we see the experimental result as well, these are also in the limits. So for the Tier 1, it was around 2.15 kilowatt. For the Tier 2, it was around 1.96 kilowatt.
Sir, sorry to interrupt. Your 9 minutes over, so kindly wrap up.
Yeah, I will wrap up in this. So actually, I have some problem in the internet, so I didn't sort it out, and then I have some problem in the presentation as well. When we see the comparison of the results for the Tier 1, it was around 3,880 kilogram. For the Tier 2, it was higher, 4,050 kilogram. Because of the core, we have to minimize the losses, due to which we have to increase the size of the core, which is thus in the higher weight. When we see the cost of the Tier 2 was around 3.5 times higher than the cost of Tier 1. So this is also a conclusion as well. You can see the prototype of the transformer we have made it for the Tier 2. So that I'm concluding my presentation here. You can see that we have to be in the limit, and Tier 2 is much more efficient as compared to the Tier 1 transformer. But there's a price difference that the price of the Tier 2 transformer was around 3.5 times more expensive than the Tier 1. Similarly, the weight of the Tier 2 is also higher as compared to the Tier 1. So we have to see where we need it. For the Europe, now it is compulsory to make the Tier 2 transformer. But in the different part of the world right now, at the last time we have a order from the Saudi Arabia that they need a Tier 1 transformer. So it depends on the countries, but for the Europe, it is now mandatory to make the Tier 2 transformer. Thank you for listening, and I again want to say sorry that I have some problem with the internet and then I have a presentation. Thank you for listening. If you have any question, I'm here.
Yes, Dr. Kamran, I have one question. Actually, how do this Tier 2 transformer handle non-linear type of loads? Means that voltage or some kind of power related, all these things.
Actually, it doesn't matter whether it's a Tier 2 or Tier 1. It deals similarly with the linear or non-linear load. We
Okay.
just have to make it in the limits. So as I told you that in the Europe in the 2014 they started the Tier 1. From the 2021 I give in all of my paper that when they started the Tier 2. So you can see that from the 2021 in the Europe you must have to make the Tier 2. Doesn't matter linear load or non-linear load. So we have to make load losses or no load losses in the limit, so that other design is similar. There's no difference with the linear or non-linear.
Oh, so
Am I,
means
am I clear?
yeah. Okay. One more. How does this temperature rises and cooling mechanism efficiency vary between Tier 1 and Tier 2 transformer?
Actually, when we talk about the load losses, we can see in the table, load losses are almost same. Load losses mainly affect the temperature. So in the limits, generally for the windings, we have a maximum 100 Celsius for the winding rise in the temperature. So as I told you that if load losses are same, there's a no big difference in the temperature. So generally there's a no difference in the temperature, but we have to make 2 or 3 Celsius less in the Tier 2 as compared to the Tier 1
So
to
is
make
it
the Tier 2.
So is it
Little bit, yeah.
affecting long-term performance?
Yeah, of course, it affect the long-term performance, because you can see in the table that Tier 2 has a less no load losses, so that means less temperature. Maybe it will also increase some of the life of the transformer as well due to the 1 or 2 degree Celsius less temperature.
Okay, Dr. Kamran, very good. Thank you.
Thank you so much for listening, and again excuse that I have some problem here and I was out of time.
Okay.
Thank you so much.
Thank you, sir. Up next, we have Sahar El Kaduri. She is presenting the paper title Evaluating Power and Memory Consumption of AES and EAS Crypto Processing on Arduino. Ma'am, are you there? Ma'am,
Yes,
Sahar,
I'm
ma'am.
here.
Okay,
Now,
ma'am, you can present
yes.
your presentation.
Yes.
Presentation.
Kamaran sir,
Yeah.
kindly mute your mic. Yeah, thank you.
Yes, it's appear.
Yeah, it's visible. You can start.
Okay. And good morning, everyone. My name is Dr. Sahar Lazem Kadouri.
Now, ma'am,
I
would you present it in slideshow mode?
is not appear.
Uh, please present the slides in slideshow mode.
Yes, I
Uh,
share it.
Actually, it's not in a slideshow mode.
Okay. Might be the net connection.
Okay, ma'am. You can proceed.
No. Okay. Hi, my name is Dr. Sahar Lazem Kaduri. I'm pleased to present our research title, Evaluating Power and Memory Consumption of IAS and DAS Crypto Processing on Arduino. This work was conducted by collaboration of Ola Tarak, Salem, and عفوا قتيبة إبراهيم علي. Introduction. The Internet of Things is a system of devices with different identified exchange information via a network. Through majority of
Ma'am,
IoT devices,
sorry to interrupt, but the slides are not moving. It's still on introductions. First slide.
Internet of Things is a system of devices with different identities and can exchange information via a network. Through majority of IoT devices are being hacked, as it's seen for the last several years. To prove how susceptible user with any of these devices in their system are. Cryptology is a technique that applies to a communication process by encoding, decoding, modify the message being transmitted during communication process, so that only the intended reception of that message is fully aware of the information within it. The two commonly used balanced encryption algorithms are DAS and IAS. The research goals. The aims of scope of this research are assess the reliability implementation of a cryptographic software in low memory devices like Arduino Mega 2560. Analyze and compare the performance of AS and DS algorithm in the concept of memory usage, execution time, and power consumption. Further, it will guarantee safe transfer of data through Bluetooth and devices that capture and transfer information, with emphasis on improving firmware level security to chip hardware. Choose secure and efficient cryptographic algorithm for limited resource systems to IoT and embedded system. In this figure, the circuit is presented for carrying sensor data and receiving the signal. The practical part consists of two Arduino board Mega connected through two Bluetooth HC05 in master and slave mode. There are four sensors: PIR, photo sensor, temperature, photo sensor, temperature and humidity. Temperature and humidity sensor. A program with DAS as code, the sensor value read as well as converted in an encryption manner and then sent to the another port. The encryption process of the data involves the following step. First, the controller starts read data from the available sensor. New data is converted to an 8-bit string, and with extra data of is 60 byte long for DS encryption. For DS encryption, 8-byte key is used, whereas AES required 60 byte or 60 digit. The encryption process works with data block of size 8 byte for DS and 60 byte for AES. While encryption and decryption times taken can be known and observed by using serial monitoring, especially when using DS and AES encryption on an Arduino system. It also guarantees ciphertext, which is transmitted to the second Arduino through a Bluetooth modem. Therefore, the speed of encryption and decryption analysis, the power consumption analysis, and the memory usage analysis once the signals are exchanged between the ports. Memory use. Memory use means the number of functions on algorithm which make it the proper criteria for estimating DS and AES algorithm. الAS consume more memory for SRAM and EEPROM for Bluetooth enabled Arduino devices at 9600 bit per second bandwidth as compared to DS in view of larger block and key size as presented in this table. In particular, AES needs about 4.3 kilobytes of flash memory as presented in this figure, and the DS needs 5.6 kilobyte as presented in this figure. The time taken to encrypt and decrypt a message using AES and DS algorithm at 96 bit per second were examined for available size of data as shown in this figure and this figure. AES is faster than DS in terms of encryption time because it has better structure. That is while DS offer the 60 round of encryption, AES round have only 8 round to offer, and therefore they take off both encryption as well as decryption complete in less time. The power consumption by the first Arduino is checked using the Arduino Uno board and not by a digital meter. The power of the transmitter during the encryption and decryption process by AES and DS algorithm was measured when tested over different data rate. AES and DS is relatively close, the latter using more power perhaps due to so many encryption cycles. DS consume more power. DS consume more power of algorithm that does require less power consumption, and it is recommended to use in limited power condition. This slide evaluates the computational energy and memory overhead of AES and DS algorithms mathematical model based on results presented in the previous slides. From this table, it can be noted that DS incurred high computational computational overhead due to its longer encryption and decryption times. This theoretical evaluation demonstrates the trade-off between AES and DAS. The AES better suits for resource-constrained IoT environment due to its low computational energy overhead and memory requirement. In our research, we suggest to utilize encoder-decoder architecture based on one convolutional layer as part of its methodology. This method employs an encoder followed by symmetric encoder and by symmetric decoder. Each block inside the encoder byte contains one convolutional layer lowered by RELU layer, activation layer, and max pooling layer. Each decoder block contains 3 layers, which include one conventional layer followed by RELU activation layer and upsampling layer, and one dimensional convolutional layer followed by a sigmoid activation function. For each previous layer, the kernel size is 3. One convolutional layer named convolution 1 every C. Apply sigmoid activation when used for classifying features with C representing the number of classes. During optimization, the loss calculation occurs by comparing reconstructed output vector against original input vector before the backward propagation takes place. The input layer and the output layer are 4 by 10 size, where the number 4 represents the number of input features for input from 4 sensor as shown in figure 1, and the number of 10 representing the number of the sample for each reading sensor. The number filter is chosen randomly to match the size of the type memories built in the Arduino Mega. The autoencoding model are learned using the following training parameter.
Ma'am, sorry to interrupt. Your 9 minutes are over, so kindly wrap up.
Okay, I will finish. This model is considered previous model is building using Python 3.8 software using a framework of the TensorFlow. Conclusion: the result prove that DS is less efficient power-wise than AS, which means that it requires more energy for same encryption jobs. DS has stability longer encryption than AES. Flash memory required is higher in DS and AS, further emphasizing that it is used more resources. IAS is more effective to be used in secure and resource-limited environment due to better speed, energy consumption, and better memory management. Auto-encoding running on Arduino device deliver efficiently alongside the detection capability, but their implementation face limitation in memory capacity and consume high amount of power and exposes them to security threat. Thank you for listening.
Okay, Seher, I have one question. Have tested the scalability about regarding any larger data set stream or any real-time sensor integration have tested in your implementation part?
For encoding and encoding architecture,
Yeah. For larger data set or real-time sensor integration have tested?
pardon, please can you repeat?
Yeah, I have some basic question actually. Uh, have you tested the scalability with the larger data set stream or any real-time sensor integration?
Please, no
Okay.
sound.
Hello. Am I audible, Seher? Hello?
Yes,
Hello?
ma'am, you are audible.
Okay. I think her internet issue is there.
Sir, ma'am, are you able to hear me? Hello, ma'am. Sir, ma'am.
No, I think not. You can continue with the next presenter.
Okay, ma'am. Thank you, sir, ma'am. You can switch off your presentation. Up next, we have Ridya P. She is presenting the paper title Gate Reason, a lightweight gate recognition approach augmented with statistical reasoning. Ridya ma'am, are you there?
Yes, I am there.
Okay,
Can,
ma'am, you can
can I-
start.
Okay, thank you. So can you hear my can you see my PPT?
Yeah, ma'am, it's visible. You can start.
Okay, thank you. So I'm Hridya. Good morning, all. I'm Hridya. I am working as a PhD student at the Center for Internet Studies and Artificial Intelligence, Amrita Vishwavidyapeetham, India. So my topic is gate reason, a lightweight gate recognition application augmented with statistical reasoning. So these are the outline of my presentation: introduction, aim and objectives, methods, experimental results, conclusion, discussions, and future perspective. So as of now, all know that what is biometrics. Biometrics is like identification of a person or individual automatically with individuals' unique characteristics. So here we can see two types of biometrics are there. First one is physiological and the another one is behavioral. So physiological includes iris, fingerprint, ear, face, vein print, hand recognition, DNA, etc. And behavioral is like voice, gait, and signature. I have selected gait because it is like we can, you don't have to know, the person do not have to interfere into the training process and all. You can do everything like without person's knowledge, but you can take his individuality or secret face and all will not be recognized outside. So like that, with privacy, preserving the privacy, we can do the recognition of a person. So gait recognition is a promising biometric technique method that identifies individuals by analyzing the walking pattern. So it includes a trade-off between high accuracy and the real-time performance, especially in a constrained environment. So we have proposed a gait reason, which is a lightweight gait recognition approach that leverages statistical reasoning techniques, which is fast and efficient. So what is the objective? Is to develop a real-time gait recognition method that is both computationally efficient and robust. So the objectives are to utilize the statistical features like SSIM, Euclidean distance, skewness, kurtosis, etc. And also to maintain high recognition performance under noisy and unconstrained conditions. And to enable deployment on edge devices and scenarios with limited computational resources. So what are all the methods? The first one is like to pre-process the data, extract silhouettes, and compute GEI images from input video frames. Next is feature computation, that is calculate all the statistical metrics. Then fusion strategy, to combine these metrics using a weighted summation to produce a similarity score. Next is evaluate the results based on the standard dataset like SAB, GHU video dataset. And we will be applying some noises to mimic the real-time scenario. So why the statistical techniques? We have selected like Euclidean distance. It will be measuring the straight line distance between two gate feature vectors, and efficient for comparing comparing features of two gates to find the most similar one. Simple to compute, light for real-time applications. Next is structural similarity index measure. It evaluates the similarity between two GEIs by assessing changes in luminous, contrast, and structure. Robust technical variations like camera noise, lighting changes, or occlusions. And it ensures the structural consistency, making it ideal for visual comparison. Next is the standard deviation. It measures the spread of or dispersion of pixel intensities within a gate image. So it helps to identify patterns of movement variation, and useful for detecting subtle movements in gait caused by fatigue or injury. So if a person is walking in a different way, or if he has an injury and all, so it can be handled with using standard deviation. Next is QNS, evaluates the asymmetry of pixel intensity distribution, detects abnormalities or imbalances in walking patterns, enhances recognition of individuals with distinct posture or irregular movements. Last one is kurtosis, measure the sharpness of the intensity distribution, helps in identifying gait patterns with pronounced peaks or flowness, effectiveness in identifying individuals with exaggerated or subtle gait movements. So this is the reason why we have selected the features. And last one, we will be calculating the weighted fusion of these metrics. So weighted calculation will be handled with this equation. So what are the experimental results based on these results? So I have compared this with the baseline GI accuracy and baseline reasoning accuracy. Baseline is like just comparing the template matching using Euclidean distance only, and we will compare it with the plus reasoning, added a reasoning statistical feature. So, and we have added the noise levels like sigma square as like 0.002, 0.01, 0.05, and 0.1. So, and the processing time is also, and we can see that there is not much processing difference is there after adding the reasoning techniques. So these are all the experimental results. And this is the cumulative match characteristic curve of hybrid method, that is statistical method, including statistical method under zero noise only. So and you can see the rank 1 and rank 10, rank 1 to rank 10, the accuracy is increasing from 99.2 to almost 99.9. So next is the comparison with the existing models. So I've selected gate set, gate net, gate part with our gate reason. So it has achieved a little more better accuracy. This is on CASIA-B dataset, and it has different parts like normal walking. NM means normal walking, BG background, and the CL is like BG is carrying backpack. CL is like coat, wearing coat. So these are the different data sets. And the another data set is OUMBLP data set. That I have tested with the gate set, gate net, and our gate reason. And the accuracy. So in order to find out
Sorry
the
to interrupt you, ma'am, but
Yeah.
you have 9 minutes out.
Okay, I'll finish now. So next is like a GHU video dataset. In order to get the real-time data, I have selected the GHU video dataset, and the accuracy is also here. Average inference time is 8 minutes, FPS 125 FPS. So this is experimental results on misclassified examples. These are like false, problems which in our model, that is, if the noise is more, there is a high chance to give the less accuracy. So ablation studies to identify which model, which feature is giving more accuracy or more importance. So here you can see no skewness is having almost, if you remove no skewness, it is giving almost similar. But some situations it is giving more accuracy, means giving more information. This is the noise level and processing time graph. Then conclusion is like it offers a lightweight, efficient solution for real-time gate recognition, balances need for fast inference with adequate accuracy. And it is ideal for deployment in devices like discussions are strength, rapid processing and robust performance. And the integration like offers potential to complement high accuracy methods and dual model framework. So future perspective is like to explore hybrid approaches, that is combine gate reasons with the deep learning architectures without increasing the time. So extend the model, incorporate more modalities like optical flow, depth, or 3D data. And it will be investigate to adaptive fusion strategies to dynamically balance accuracy and speed based on the conditions. So, so thank you. Is there any questions about this?
Yes, Rida.
Yes.
Actually, a basic question. What data set you were used for training and evaluation purpose?
Yeah, for I haven't trained with the cross databases, ma'am. If I am using only one OUMB and LP data set, then I will be taking that only for training and testing, like 80% for training, 20% for testing, like that. But in the yeah, like that I have done, and we have the plan to implement it in our office also. Currently we have the face recognition alone, so slowly we need a faster one, gate recognition, so that also we are planning.
And how the model handle this interclass similarity? This
In
grid reason? Yeah.
interclass similarity. Okay. Okay. Then so that is like just a similarity between the GEIs, no, ma'am. So that that weighted average weighted values only, that value we will be keeping like 0.9 above or 0.8, like that will be out of 1 we will be calculating above 0.5, then there is a chance that it is that person. So like that calculation we are planning.
Okay, so you have tested the environment such as in a public surveillance, right?
Yeah, public surveillance in GHU dataset only we have tested. Otherwise, we need to do in our means we just tested in our lab. We have so many people there. So there in staff, students, so many people are there. So around 2,000 people in our lab alone, and our university, even more people are there. So
Okay.
so like that, we are planning to do it in a larger scale. I just started with the real time, how it will be like that. So, and I have done with the deep learning model also. That is another work. So if it is a deep learning model, it is a very heavy, like attention gate and all. We have done that, but we wanted a lightweight version of that. For that, we have used this gate reason.
Okay. Okay, Rida, very good.
Okay,
Very
thank you,
nice.
ma'am.
Thank you, Ritya, ma'am.
Okay.
Up next, we have Rohit MN. He is presenting the paper title Synergizing Raga Therapy and Nonlinear Computational Model for Enhancing Neuronal Healing and Mental Well-being. Rohit sir, are you there?
Yes, sir. Yes, sir. Very good morning.
Okay, sir. Good morning. You can start your presentation.
Okay, hope my screen is visible to you.
Yes, sir, it's visible.
Okay, thank you very much. So, very good morning to all the team members who have been joined over here for this presentation. I am Rohit Aman, Assistant Professor in the Department of Electronics and Communication Engineering at JSS Science and Technology University in India. My topic is about the synergizing the raga therapy and the non-linear computational model for enhancing the neuronal healing and the mental health being. So this would come across with respect to the what would be I would be presenting in today's presentation, like the proposed title of the work, the scientific background, the literature survey, methodology, and why the reasons for choosing them particular ragas and all those things. The methodology, the computational approach, the results and comparative study, the conclusion, and the future scope. So title justification, let me first give you the title which I have given is a synergizing raga therapy. Why synergizing? Because I'm trying to combine or I'm trying to coordinate the activities, what is going to be produced instead of having with the sum of the separate effects. I would just try to take the joint effect, which would be more greater in its approach. And here, which I have chosen is a raga therapy, which is the one which is going to channelize the vibrations, what has been emanating from the sounds to uplift the level of the consciousness. Secondly, with respect to the non-linear model, because all these particular values which has been taken from a human being, they're all usually be in terms of a dynamic data which we would be getting, and they also try to contain some significant uncertainties. Talking with respect to the second half of this work, that is in terms of the neuronal healing which we are trying to take, based on this particular raga therapy, what is it going to contribute to the mental health being, where we are trying to promoting the recovery from the neurological disorders, the stress levels, and the trauma level. So this is just title justification which I just wanted to give. Giving with respect to the scientific background as such, so the power of our music, my musical vibrations, because it has been seen in every of the in the universe with respect to all the plants, animals, and every being. A human body which has been constrained with something around 72,000 astral nerves, which has basically been called as nadis, and it has also been connected with respect to the 7 chakras. So in Indian music, we basically have 7 basic swaras. So those 7 swaras which is connected to those 7 chakras, and those 7 chakras which is connected to the 72,000 astral nerves. So any disturbance which has been caused into the vibrations, means there's some rhythmic vibrations which has been caused to any of these particular chakras, which is nothing but the cause of some particular kind of a disease. So my area of the focus is I'm trying to see what is the influence of this Indian classical raga structure on our human body, while when a person is trying to listen and he's trying to express some kind of an emotions, so that I'm trying to capture using some EEG signals. So this is a certain small literature survey which I have just shown over here. So coming to how I had worked over here, the methodology was I just tried with something around 30 healthy patients, where out of which some 15 were the male patients and the 15 female patients were there. Like each participant was being made to be exposure to this particular music therapy or the raga therapy, where particularly I've considered the 3 different types of ragas. One is Shankarabaranam, Bhairavi, and the Hamsadvani raga. This particular data I've taken up to an auto-regression model, which I've tried to apply to predict what is the EEG signal behavior. That is, during the process of the exposure to that music, the EEG signals, then also the raga therapy is being given during that time also, and post to the exposure to the music therapy, what is the 3 cases. So in 3 different sections, I have tried to collect this particular set of data. So what was my key finding in terms of this? One is with respect to Shankarabaranam major raga, where the alpha activity was totally being enhanced. That means the relaxation and the emotional stability was a significant role which was being played with respect to this particular raga. And the second raga which I had tried was about the Hamsadvani raga, where the beta activity was predominantly being increased. So if the beta activity, beta waves has been increased, so I can see that there is an improved concentration and the mental clarity which has been there. And the third one which I tried was about the Bhairavi raga, where there was a moderate shift in terms of the alpha and the theta value. So that tried to reduce the total anxiety and the stress levels. So what is the basic reason behind selecting these particular set of ragas? Let me just give you. So the first one is a Shankarabaranam raga, where basically with respect to this is a major scale of the raga where all the 7 swaras has actually been involved into this. The basic idea, the impact of this is we could see that the ideal stress reduction and the mental relaxation was actually being observed into this particular, listening to this particular raga. So selection was being an ability where we try to induce a relaxation, and we also saw the foster emotional balance which was being seen from an individuals. So based my expected EEG transformation was in terms of an alpha waves and in terms of a theta waves was clearly being obtained to me. The second one with respect to the Bhairavi raga, where I saw that the deeply emotional raga, this is actually a very deeply emotional raga where we see 2 different types of the swaras which has been seen, observed. So what is its impact on the mental state? Impact was the total reduction in terms of an anxiety, the mental status, stress, and the emotional release which was being observed. So using this particular raga, I actually observed that the alpha waves, which promotes the relaxation, the theta waves was also being increased, which encourages the emotional release and the stress reduction. And in terms of the beta waves, which totally reduce the overactive thinking and the anxiety levels. Lastly, with respect to the Hamsadvani raga, which actually improved the concentration and the mental clarity of that particular any of an individual which was being there. My expected EEG transformation, which I observed, was the beta waves and the alpha waves was tremendously being increased after the person listening to this particular raga, because it boosted their mental clarity and improves their concentration and induced very much alertness towards listening to this particular kind of a raga. So this was the 3 reasons why I chose this particular 3 different ragas. So how did I do this procedure? I basically used a 10 to 20 EEG system channel locations where the 4 different regions of our brain, which was actually been where we placed this 20 LEDs, the leads which was being placed. And based on this, we have tried to collect the alpha, beta, and the theta waves. That is to analyze the relaxation, analyze the concentration, analyze the emotional states. So these were the particular set of channels which basically gave us the clear idea behind what is the waves, how the waves is actually been appearing at that particular stages. So what was a step which was being involved in this transformation of this raw EEG signals? The first one was in terms of an EEG signal pre-processing, where in this, the first one was the noise removal, where I try to use a notch filter over here because I have to remove all the power line noise and the drift, because usually in EEG signals, the power line interference will be present. That power line interference has to be totally been removed. So that's the first step which I did. The second step, which was in terms of a band pass filter, which I chose between the 0.5 to 50 hertz. Well, typically it has been analyzed within this particular frequency range itself. I'm able to retain only the relevant brain activity frequencies I have retained with this. Yes, I got the brain waves of the signals. Then I have to go with the segmentation. So where the approaching kind of a method, that is, I try to create a very meaningful time windows for the further analysis. With just 2 seconds, I've cut it out with the entire EEG signals. Then finally, the artifact removal, which I have to do, that is during that particular EEG recording, there might be some kind of an eye blink or the muzzle artifacts would be there. So I have to go with an independent component analysis. It removed out all the unwanted kind of an artifacts. The second kind of a step is about the feature extraction. When in the feature extraction, I basically observed about the power spectral kind of a density, where the exact useful features for the analysis was being taken. That is, the need of an alpha, beta, and the theta band powers was actually being identified. That is the predominant kind of a frequencies which was being used. So this is the where I actually analyze the effect of the different ragas on this particular EEG signals. So where I used an FFT method, that is a fast Fourier transform method, which was actually being utilized over here. Then coherence part, where I try to see the measuring the synchronization between the 2 different types of an EEG signals, where different ragas was actually being used, where I used a magnitude square coherence method, which was being used over here. And then lastly, which I went with respect to the peak frequency analysis, where I try to identify the most dominant frequencies of the EEG signals, I basically try to identify over here. Step 3 was about the statistical analysis and the interpretation. Since I could not check with only one group of sets or something, if it was 2 groups, I could have used the t-test. And if it was 3 or more groups, then I have also used the ANOVA. So both I have used just to check if different ragas significantly influence on this EEG features or not. So I verified with that. Then the correlation analysis, where I try to check how this EEG features is example with respect to your alpha power, the coherence, how it is actually relating to your relaxation or the stress level. Because the higher the alpha power correlates with respect to the lower stress level, higher the coherence correlates with respect to the better focus. So this is what the correlation analysis which I basically obtained over here. And lastly, with respect to the regression analysis, where I would able to predict the cognitive states based on the EEG set of the parameters. Keeping all these certain set of data, I went into the computational approach using this AR model. But the first step was about the feature extraction, which I did. That is the compute the power spectral density for each and every frequency band, which I took. Then the step 2 was in terms of the model fitting. I've tried to put the auto regression model to each of the frequency band of this EEG data, so that I would be able to predict what is the future value of this alpha band activity based on the previous set of the activity. Then the step 3 was about the forecasting that is being used in the AR model in order to predict the future EEG signal values during this period of this raga which was being heard. Then the model evaluation which was being done, where I try to use the mean square error so that I could be able to evaluate the prediction error between the model forecast EEG values and the actual observed EEG values during this entire exposure. This was a set of the results and the comparative data which I had basically obtained with 3 different ragas, pre to the exposure, during the exposure, and the post exposure. If you can observe over here, in terms of different during the exposure, what is the level in which the alpha band value which is being there, and also in terms of the beta band value, what is the changeover which is actually being there. And also this is a comparative analysis with respect to the EEG power spectral density in terms of a theta band value with respect to all 3 different ragas. And finally, with the AR model, predictive accuracy, what has been actually been observed, is also being depicted over here. So just to
So,
try to summarize you with respect to this statistical kind of analysis, what we have done. So I have tried to take the mean values, that is, if you can observe over here in the table, there is a mean increase of something around 2.37 microvolts, which has been seen in terms of an alpha wave amplitude, because after the raga exposure, where it indicates the strong physiological kind of a response which has actually been obtained. Then we saw with respect to the pair T sample test, which was being seen. So I can see that the difference in the alpha wave amplitude is being statistically been robust, which has actually been observed over there.
sorry
So
to
that
interrupt you,
with
sir.
respect to the stand,
Your
yes, sir.
time is up.
Yeah. So standard deviation is just to reflect the variability of the EEG signals across the different individuals. So coming to a conclusion, where I've tried to integrate the raga therapy with respect to the AR models and the distinct EEG changes which has actually been observed, and also in terms of an AR model predictive accuracy which has actually been obtained for me in terms of this, and lastly the potential for the personalized kind of a therapy which can be observed in terms of the neurological imaging. So these are some of the references which I have obtained. So thank you for all your time. Any questions as such, I'm happy to take with this.
Yeah, Rohit, very nice work. I'm impressed.
Thank you, sir. Thank you,
Actually,
ma'am.
few questions actually, Rohit,
Yes, ma'am.
related to your data set collection. How you collect the data set?
Okay, I had this was in a hospital. I in what I can tell you, in Mysore in Karnataka, we have an hospital called Gopal Gowda Hospital, where I took some 30 patients over there. So I made them to listen to this particular music. So first, I just made all healthy patients, all 30 and healthy patients itself. I took them. So I just made them to listen to the music first. Sorry, first the EEG was being collected. During the process itself, the music was being made to be heard to them, and then post to the music hearing, how was the EEG which was being collected. So this was the total way which I actually worked, madam.
Okay. And what evaluation metrics or validation data set were used to access some efficiency like Raga computational approach, combined
That is
Raga computational approach?
that is in terms of this. You're asking related to?
Related to the metrics validation, evaluation metrics validation.
Validation, look, like the validation part was the biggest challenge for me, ma'am. The reason is, so I'm not getting any based kind of a base paper or any base work which has not actually come, so just to prove with this. So that's the reason I'm trying to develop some through 2 to 3 kind of mathematical models itself. So using these mathematical models, I would be able to come to a final conclusion as such.
Okay,
Okay.
Rohit, very good, very good.
Thank you, madam. Thank you.
Thank you, sir. Up next, we have Mifachul Huda. He is presenting the paper title System Development for Digital Leadership Administration, a Critical Review. Huda sir, are you there? I think he is not there again. We'll move further. So up next we have Chada Narasimha Reddy. He is presenting Vidya Vedha AI-driven personalized learning for smarter education.
Yes, sir. Am I
Yes, you
audible, sir?
can. Yes, sir. You can start your presentation now.
Is my presentation visible
Yeah,
and
yes, sir.
audible?
It's visible.
So today I am here to present about Vidya Vida AI-driven personalized learning for smarter education. So let us come to the problem statement. Today, many of the students, me myself as a student, we have been spread with the information overloaded, excessive, and unfiltered online education content. Wherever you go in this educational era, there is complete trade of knowledge into different platforms. Whether it is YouTube, Google, or ChatGPT, anywhere you can get excessive content. And but those content, how personalized it is a question. Today's the major question is personalization, because all the regular coaching approaches or even you do follow one-on-one approach, like the teach and the feedback sessions are very low. So They provide non-interactive content or generic content. It is very difficult to identify the relevant curriculum. Suppose a student is studying in an UG or taking a course in an university. He has no idea whether that aligns with his curriculum or that aligns with his learning goals. The learning goals of a user may be different to that of a content that is taught, because content is anyway vast, and the thing that we need or we need to extract may be very small, and those tip of the iceberg to extract, we need more personalization such that which meets our requirements. So in today's generation, there is an absence of integrated assessment and real-time feedback of progress trackers. Students often struggle with retention and engagement due to unstructured learning paths. So we have developed Vidya Veda, an AI-powered personalized learning platform tailored to individual students. Here, generally, there are we process on YouTube. Generally, we take videos from YouTube. We use summarization, transcripts, quizzes, and analyze the students' performance based on those. So here you can see workflow of our Vidya Veda LLM model. Here, generally, we take an user input. Example like topic name. Suppose I like an example here, machine learning, and what you want to learn in machine learning subtopic. Here, SDN is a subtopic. So there are two things that you can start doing from here. Like you can ask it to generate a PPT or a slide content. So it itself generates a PPT, and you can see a clear difference between this and an AI PPT, which are like tome or everything. Because tome or everything, when you see the PPT, you can say that it is a PPT generated by AI. But when you see our generated by Vidya Vida, it looks like original PPT generated by human. The reason is we have used PPTX in Python. We have used PPTX library. We have prompted for each and every different type of templates. So there are variety of templates, and we have prompted what type of structuring you want. It might be a flow diagram, flow chart, or a sequential format, and many more. And we have also given the keywords. We have extracted the keywords, and we have taken the web search to write the images into the PPT. So this is one way. And if you want to learn knowledge through the videos, generally the open access platform to learn is mostly YouTube. And generally in these YouTube, there is a lot of content. Example, when you place your search for machine learning, generally YouTube recommends you some algorithm. Based on some algorithm, it recommends you some set of videos. And those algorithms, according to our research, we came to know that mostly it will be on most number of likes, most number of comments. But there is something even more. When you even go into the metadata of it, there is something called educational content. For educational content, there is a number given, and when you search the content based on these type of data, you'll be getting very specific values. And we have make it not just providing you a simple video. And how there may be a question, why do you think it is better than YouTube? Because we'll say a simple example. Just instead of putting you a video, we have given you a personalization of 3-step personalization. First step, we are asking you topic subtopic, and we are extracting the mp3 file, the text file of the video, and we have checking the cosine similarity with your topic, like how well the content in the video is assigned with your topic name. If your content in the video is well assigned with your topic name, then that's a good video, and that's a tick number 1 done. Now, what do you want to learn? Some people want to just learn an overview, and some people want to see the most rated videos. Like they'll be more preferring like what's the high rated videos, like you may have a high number of views, high number of likes. So those people are attracted to those videos because that's the most popular video. So that's the second preference. Are you interested in going to high likes, high comments, or are you interested more onto the duration? Some people want only overview. They want a 5-minute overcap. They don't want to get into the 40-minute video. So we have given 3 to 4 layers of personalization. So this personalization helps us to identify whether the user gets an appropriate video that he wants. And once he gets that video, as already we have the MP file, we have used a BERT model to create the summary of that video. So that's by looking at that summary, and we have also created timestamps for that video. Generally, for some videos in YouTube, timestamps are available. For other videos, there are no timestamps, and these timestamps help us to get into a particular point of time where the topic is being taught. So we have provided these timestamps for those videos. This helps the users to pinpoint at a particular time at which they want to listen. And now after so these are the two things. One is PPT generation and one is video stream with timestamps. And these videos, what are the MP3 files we are extracted, that we are also summarizing it. And one more interesting point is about the PPT. When your PPT is there on your screen and there is a PPT summarization for you, which explains each slide for you as a teacher. So how good it would be if you just ask it a topic and it generates a PPT and it starts explaining. That's what is our work basically. So when it starts explaining the product, it's nothing but an LLM model. So it is training to explain those PPT. And once it starts explaining those PPT, if you have any question at any point of time, suppose I don't want the slide, like my slides are not in an order, I want to add something in between the slide, you can just stop. And we have used iframes iframes to analyze the PPT. And now you can use now you can add any slide you want. Like I can ask you to add any slide. I want a slide regarding some this topic which is not covered. It immediately adds you the new slide and the whole PPT is refreshed. And again you can so this is what we have done. And now the one more feature what it has is, when you have generally student have some existing PDF or something some materials with them, and they want to take test or exam based on only their materials. Like suppose a university student or something is learning, he has some material provided by his university, and he want to learn the topic up to that extent so that he can be good at with those topics. So in that cases, once the PDF is uploaded to our application, they can take the exam. The question is of MCQs in the blanks. So those will help us to analyze the report of the student, how well he is in this topic, what are his weaknesses, and how can it be done. So this is the overall workflow of our work. So as I told you, we have used user input and topic reposing. Student enters the topic of interest through the web interface. The system uses NLP to analyze the understanding the topic concept. And we have used and we have also used RAG, and we have used APIs for fetching, and APIs for fetching the YouTube metadata is fetched using APIs. And we have used the context and summarization and mapped it with the videos, and then we have recommending a videos. So you can upload your PDF and your material here. So we have also used the AI chatbot integration quiz generation modules. So once we'll come for the performance and performance models.
Sorry to
So
interrupt you, sir. Your time is up. Time is up.
okay, just I'll proceed the results. So these are our results. Generally, we have good schematic similarity, bird score, Raphael score, and in this question and answer model which you can see here, and these are the summarization matrices or summarization of the video. These are the results of the LLMs, and you can also see PPT generation results on the screen. These indicate that our model has used a really good bird score and a good reading is and very minimum toxicity, making it a good product. So we can say this by using our platform, you can bridge the gap between AI-based personalized education and there is a further more work needed so that more personalization can be included. Thank you. I'm open for questions. Any questions?
Okay, Narsimha, have one question. What type of feature were most predictive in the adapting this learning path?
I did not get the question. Could you once elaborate?
No, you have explored that all types of features, right?
Yes, ma'am.
So yeah. So for that
But mainly
purpose, which one is the
PPT generation was mostly like, ma'am, when we checked across students, because
Mhm.
PPT generation was taking huge time for them, and if they generate a PPT using AI, they are
Mhm.
getting like with any work, people are just simply saying that it's an AI generated PPT. And when some of
Oh,
those from our university started using our own Vidya Veda, they tend to see a difference. Like it's not the ordinary PPT. We have given 4 to 5 templates, and we are working to improve on more templates. And they are seeing it as a original PPT, like a human-made PPT, and they can
okay.
edit it at any point of time. That's a beauty of Vidya Veda. Like if I want to edit it in real time, I can edit it.
Acha. Okay, and one more thing that just curious that backend infrastructure supported any scalability like cloud deployment or microservices or any kind of edge computing in the backend infrastructure?
Now, generally, we have developed an LLM. We have used two of our, we have very good CPU and GPU format, but to scale it around, we are thinking to
Hmm.
use it on, like, we
It
have
might be
given the
for the
whole,
largest for large. Yeah, yeah.
yes, ma'am, we are thinking it to deploy because we have directly now it as, we have used it as an open source in our GitHub. We are asking the students to just download the whole code and use it.
Mm-hmm.
And once if you want to have a like versatile thing, you have to run it on a cloud because when you have to serve multiple requests on a single time. Now actually we are giving the whole open source code and we are asking them students to just run the code and use it.
Okay. One suggestion that if your university students are satisfied and they are giving the good feedback, then definitely you need to be think about that. You have to uh, that is deploy this complete code in the cloud or cloud deployment, right?
Yes,
And
ma'am.
for the performance also need to be checked afterwards, right?
Yes, ma'am. Yes, ma'am.
Okay, okay, Narsimha, very good.
Thank you.
Thank you, sir. So all the presentations are done. I sincerely thank our authors and their excellent presentations and contribution in this session, and all our participants for being part of this international conference. I hope this session was informative enough. We, on the behalf of whole team, thank you for the support and during this 10th version and the previous 9th version of the conference. We will be happy to have you in 11th version in 2026. All the presenters would getting be their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months and kindly cooperate with the ICTIS 2025. I thank our session chair, Dr. Disha Wankhede, for chairing the session. A token of appreciation to the chair on behalf of Team ICTIS 2025 and Global Knowledge Research Foundation and partners. Ma'am, would you like to give any closing remarks?
Yes, Siddesh. Okay. So all the participants, this conference, you have presented your paper very nicely. So it is a great honor and privilege to serve as a session chair here to engage in insightful technical session actually. Diversified topic was there. The papers presented today have demonstrated remarkable some blended cutting edge research and some new research topics I just gone through. Some practical applications and some interdisciplinary insights was there. So definitely, I'm very happy to serve as a session chair in this conference. Okay. I'm particularly impressed with the diversity of domains which we have explored from mental health, then neuroscience, eco design, transformer, like that. Many topics was there, which are some kind of personalized learning also. Okay, so as we continue with this conference, I encourage all the participants to engage in future discussions as the and ask some questions and explore the collaborative opportunity. Okay, so thank you once again for this opportunity. Okay, and thank you all the participants to joining this session. Thank you very much, Siddesh.
Thank you for your valuable presence, ma'am. I kindly request you all to switch on the cameras for a quick snapshot of the virtual conference.
Thank you so much.